these barriers. And I have a little bit of a different take on this. And so basically, I want us to think about how and what are the drivers for adopting green chemistry, and how can we move beyond these barriers. And so I have a little bit of a myth of barriers. I think that, if you can build a better mousetrap, it will be successful. So let's think about this a little bit more. If you think about the history of different industrial sectors, such as polymers and plastics, which have a very long history here. Each of these technological advancements that you see here, each one of these, whether it has been a market push or a pull from the, each one of these products that was introduced into the marketplace, it actually represented a benefit to society. So whether it be economic, or it actually worked better. Plastics and polymers were, all of these materials, from our eyeglasses to our coats, all of these things, each of them actually had a benefit to society. So it wasn't really, whereas we might have perceived it as a barrier to adoption, some of these technologies, if it's clearly better and more economical, it will be adopted. So if it has that benefit. All kinds of different industrial sectors you can think about this throughout technological advancement, from metallurgy to how we used all of these metals and each of the products that they went into and their replacements, their counterparts. We can build stronger bridges, we can build more resistant, we can build all of these things which have a clear benefit, whether it be, all would have an economic and a clear use benefit. So it clearly would be better. So you can think about all of these things throughout all of the different industrial sectors, pharmaceuticals, nanotechnology. Nanotechnology, a lot of times there is a lot of talk around the toxicity of nanotechnology, but there are very little who doubt the benefit of nanotechnology, because it's clearly stated, all of the benefits to it. So think about all the technological advancements. If it's better, it will get adopted. So traditionally, and so I'll actually bring all three of these up here. So, and this is actually from John's slide, if you caught John Warner's slide as well. It's a key point in green chemistry. So all of those benefits and technological advancements that I was mentioning before, as I said, would have an economic benefit and a performance benefit. So it would actually work better than an alternative. Where green chemistry comes in is it says, well, yes, those two have to happen. It has to be economical, and it has to perform better, or just as good as an alternative. But it also has to have an environmental benefit. That's where green chemistry comes in. And all those three together is when you get green chemistry. You can't have, and John always uses this example, you can't have a cleaner that might have an environmental benefit. If it doesn't clean, you're not going to use it. And if it doesn't have the economics, you're not going to be able to purchase that and use that. So all of these three together is really where green chemistry comes in. So as we're thinking about these barriers of, green chemistry, it's really better by design. It's really not too much. If we can make it and design it, and we have all of these three things that I mentioned, the safety, performance, and the cost, then it will be adopted in the marketplace if it has these three benefits. Just as all of the previous technological advancements were adopted because of their clear benefit. But green chemistry is a little bit trickier to nail down than polymers and plastics, or pulp and paper, or pharmaceuticals, because it touches upon all of these different industrial sectors, and it crosses all of these disciplines. And so it's a little bit trickier to understand that. And it is the realities of green chemistry. I just bring these points up just to remind people, if you haven't been here for the last 2 days too, I think it's important to remember and for me to remind you about. It is expensive to use and generate hazardous materials. It's generally, if we can use a safer material, we're going to use it. We might not have all the answers right now, and that's where that fourth point comes in. Finding solutions are challenging, and we need to still seek and find those solutions. I'll mention that a little bit more. And I bring up this John F. Kennedy quote, which I know Paul Anastas always likes to quote Kennedy as well. He's one of our greatest presidents, of course. But, you know, finding solutions are challenging, and it is difficult. Green chemistry is, and I think, really more difficult than many others, because we do have to have those three key things in order for it to be successful. But, you know, we do these things, and I love this quote, you know, we don't do it because it's easy. We don't choose this profession because it's easy. We do it because it's difficult, it's hard, and all of these solutions that will come out, all these green chemistry solutions that will come out of solving these problems, they're going to demonstrate the best of our abilities as scientists and as chemists and as engineers. It will be the best chemistry that comes out of it, and it will organize and measure the best of our energies and skills. And of course, I like that last part too, because this challenge is one we can't afford to lose. So I started talking a little bit about barriers, and I'll come back a little bit about this as well. So if you think about the actual barriers that we're faced in green chemistry and how we move past these, we do have some, and I'll go through these a little bit, each of these. We have perception, the first one. So if we have a first, I won't mention this guy on the left here, but we have this process here, this perception of green chemistry has been traditionally that anything associated with the environment or you know, with green in the name, it must not be as good. So it must have these things identified here on the left. So it must have a decreased turnover time, increased regulations, loss of productivity, a cost drain. It must be a cost drain, is what a lot of the traditional perceptions of green chemistry are. Or a decrease in performance. It somehow can't be as good. But like I said, if you go back to that definition, it must be as good, and it must have that performance. So the perception of green chemistry is shifting towards that right side of it actually increases efficiency. It's non-regulatory based science. It increased productivity if it's done and designed correctly. Decreased liability. There's a reduction in cost, huge cost savings, and you have heard it and will hear it from case studies in different industries who are practicing it. And increased performance. All of these things and all of this, it's a pretty big shift towards the right, and I think our perception is changing in green chemistry. I hope you feel it too, but I think the perception's changing. So if we think of the actual barriers, okay, maybe I can take that first one off. Maybe I can take perception away, because the perception is changing. It is excellent chemistry. It does have the performance that we might not have traditionally thought it had. So how about these other four? Capital equipment costs. So we know that this could be a barrier, depending on if it's a drop-in technology replacement or not. Yes, we do have some new technologies coming out of green chemistry, such as supercritical fluids, which require various reactors or extraction mechanisms. So it could involve new equipment and capital costs, capital investment. Not all green chemistry does involve new equipment costs and capital investment. You can, many times, are direct drop-in replacements. So I'm going to leave that one on there as yes, it is a barrier right now. It could be a barrier, not in all cases, but it is. So what about that next one? What do I mean by regulatory barriers? If you think about as new laws and regulations come along, there could be a grandfathering of older chemistries that are grandfathered in before the regulation, and so this could actually serve as a barrier for adopting a newer technology that might have that environmental benefit if they're already grandfathered in. There's when in the case of pharmaceutical industry with new formulations and new processes, if you have a new composition of matter, such as John's example yesterday, if you heard John's talk about non-covalent hybridization, if you're actually trying to manipulate the properties and you come up with a new composition of matter, even though it's the same material with a slight through a co-crystallization process, you then have to seek new approval if you have a change in your composition of matter for your pharmaceutical, your active ingredient. So this could also serve as another barrier for not shifting to a newer or better, greener technology.